Hello, my name is Saidat and I'm here to explain you about a very uncommon process called as thermit welding process. So, being a mechanical engineer, while you study the subject production technology, you can hear various types of welding process, and in your lab also you get to do arc welding and gas welding process. So you don't hear about thermit welding very much because it is very rarely used. So its application has been limited these days because of the origination of various other alternative processes. So thermite welding is generally used to weld very large plates, which are having very high thickness. So very high thickness plates include railway tracks, ship hulls, and various other applications. So thermite welding, it's a type of a chemical process of welding. So this works on the basis of a chemical reaction. So in thermite welding, a mixture called as a thermit is used. So thermit is a mixture which contains about iron oxide and aluminum. So along with these two, which are taken in a 1/3 ratio, so along with these two, you have an igniting mixture, which generally barium peroxide is used. So the use of this barium peroxide is to ignite the mixture. So I will come to that topic. So basically, thermite mixture looks something like this. So this is the crucible, and this is your setup. So this is your railway track, and a railway track or any other plate. Let us, for this example, let us take it as a railway track. So this railway track, in between these two, there is a space. So this space is generally the mold into which the metal inside the crucible melts and falls inside. So I'll tell you which metal. So you have a tapping device, you have a mold, riser, runner, heating gate, which is similar to a casting process. So basically you're casting the weld in between two plates, and later after casting the weld it is machined in order to fit properly. So this is section to weld, and this is space for the molten metal. This is the sand, and this is the slag basin, and I will also explain what the slag is. This is the molten iron, and this is the aluminum oxide slag. So when I'm about to explain you the chemical reaction, can come across aluminum oxide slag. So now let us go towards the chemical reaction which produces this immense amount of heat. So when the thermite mixture used is aluminum and iron oxide, this is the chemical reaction. So you take iron oxide and you add aluminum to it. Then after igniting the mixture, so what happens is a replacement reaction happens. The aluminum in thermite reacts with the oxygen in the ferrous oxide. So the oxide gets replaced and only molten iron is left. So aluminum oxide, being a much more a much more lighter mixture, it floats above, and the molten iron being a much more heavier liquid, it goes below. So after this process, the crucible, there's a tapping device which opens. So this tapping device opens and lets the molten iron flow into the mold cavity. So this cavity then fills the molten iron in between the two plates and cools it down, while the aluminum oxide is separated on top. So after this metal is settled inside the mold cavity, it looks something like this. So I'm talking about the picture on the right. So this is after the weld is formed, and the picture on the left is the what is happening during the weld. So the bigger pot on top is the crucible, and below where the glowing liquid is, that's the mold. That's the mold. This is the mold, and this is the tray, and this is the crucible. This is the man operating the machine, and these are the tracks. So you have clamps to hold them in place. So this process is pretty heavy because making arrangements for this process takes longer than the actual process. You believe it or not, but how much of a thermite mixture you take, it takes less than a minute to complete the process. So in 1 minute you are able to complete the weld of two thick plates. So the temperatures can reach up to 3000 degrees Celsius. So before starting the mixture, the thermite is ignited at the temperature of 1200 degrees Celsius. So after 1200 degrees Celsius, the barium peroxide burns explosively, and the temperatures reach up to 3000 degrees Celsius. So at 3000 degrees Celsius, the mixture melts and it opens the tapping device. So this mixture melts and flows below into the mold cavity. So this process is completed in a fraction of 1 minute, and so it is a very easy it's not a very easy process. You can't say it's a very easy process because it's a pretty complicated, and see the materials used are more, and it is much more heavy, and even though it takes very less amount of time, so it is limited to a very little applications. So this is a thermit welding process. So I'll show you some images which can explain it more. And this is an exothermic reaction which is happening inside the crucible. So this is the mold. So the liquid flows below into the tray, and the molten iron gets settled inside the gap in between these two plates. So before we before we melt the before the thermit gets settled inside the mold is preheated by using any mixture like oxyacetylene or propane oxygen. So generally propane oxygen is used because it is a much more quicker process of preheating. So the after preheating the mold, the liquid metal is poured inside, and you can see immense amount of heat and fumes are released, as it is an exothermic process. It releases heat, so it settles inside the mold, and the slag which is left above it gets collected in the slag trough. So this way the welding is done. So this is there for more images and more examples. So mold gets settled and it comes from the sides, and okay. So this is not only limited to railway tracks. So in case of railway tracks, we generally use iron oxide and aluminum mixture. So in order to weld high tension copper wires or very thick copper cables, thermit mixture is also used, but the mixture used is copper oxide and aluminum. So the process is simple. The aluminum replaces the oxygen, and the pure copper gets settled below, while the aluminum floats above and gets separated as slag. So this way thermit mixture welding is done. So I hope you understood what I was trying to explain. So thank you.